AI. In the previous session, we presented a multimodal RAG application with seamless integration into SharePoint for secure indexing and retrieval of in-house documents. And in this session, we're going to introduce additional functionalities that make the application more production ready. The goal is after this session, like all that's required to set up RAG within our organization is already provided, and it could be used to set up RAG against your in-house documents. As a brief introduction to Arcurve, which hosts this monthly webinar series, founded in 2006, Arcurve is a full-service technology advisory and software development company, and it guides organizations across industries on their data journey, enabling them to leverage technology for data-driven decision-making. As a quick bio about myself, I am a tech lead at Arcurve at Advanced Analytics Group. I have a doctorate in civil engineering from Memorial University with about 7 years of industry experience in AI/ML, doing simulations, generating synthetic data, especially using final element analysis, and doing a ton of pipeline stress analysis because that was my field during education. I worked at Technium FMC, Northern Crescent, AltoML, and now I'm working at Arcurve. It's been less than 3 years so far. And I'm pretty passionate about bridging the gap between engineering and tech. I enjoy playing ping pong, mountain climbing, traveling, and making and eating sushi, which is my favorite. Hand over to you, Mike.
Thanks. Yeah, so I've also got an applied background coming out of the domain as well. Worked in a number of different sectors over the years: environmental, AEC, mining, of course, and the energy side of things. Started a company in 2016 called Menome Technologies, where we built out a platform for continuously integrating data together and generating insight from it. And that was acquired by Arcurve about 5 years ago now. And so since then, I've been acting as a strategic advisor on AI projects. And when I'm not doing that sort of thing, definitely spend a lot of time in the mountains biking, and also more recently playing in my daughter's band, which has been quite entertaining.
Nice. So as for the agenda for this presentation, we will start by discussing why investing in a solid data foundation is essential, the challenges associated with shallow implementations, and what it takes to effectively address these challenges. Next, we will briefly review the architecture of the multimodal RAG, complemented by a live demo, and highlight the enhancements that have been made to the application to make it more production ready. So I now hand it over to you, Mike. Take it away.
Thanks. Yeah, so I wanted to start off the session today by speaking and addressing kind of the biggest challenges that we typically see in the context of implementing these types of AI augmented systems into the enterprise. And that's one of building trust. And this is going to very much build on the theme that my colleagues Eric Nozel, Taylor Noel, and Tony Turong spoke about at the recent YYC DataCon event, which was also highlighted in a digital journal article, which the link will be posted up on the site. It's pretty interesting. And that's the challenge associated with building trust in these sorts of systems. And it really gets into the fact that the high value implementations of AI tech in the enterprise is not really about the models themselves. It's the things that you put around and underneath the models, as it were, to make them work in the specific context of the enterprise. Next slide. So last week when I was setting up the theme around this, I sort of thought, hey, you know what would be a really great way to illustrate this whole idea is by generating an image of a trust fall. And for those of you who've done various different corporate retreats and things, this is often team building events and that kind of thing. The trust fall is sometimes featured as a way of helping team members, understand this idea of trust. And the way it works is you basically put a blindfold on usually, and you fall backwards and your colleague is supposed to catch you. So I thought, hey, you know what would be really great is if I used one of these image generator things like DALL-E or Midjourney or Stable Diffusion to generate an image of a field person, you know, falling into the waiting and ready arms of an AI model. And of course, this failed rather miserably. And as you can see, the images, no matter how I tried the prompts and so on, as of last week, the only thing I could get the AI to generate was the AI basically dropping the person, which I thought then ended up being an interesting illustration of this idea of trust and the fact that the technology by itself wasn't really there. Now, as luck would have it, if you go to the next slide, this ended up illustrating two different aspects. So the first was that these models will continue to improve and will improve very rapidly. And in a recent conversation with Bill Gates, OpenAI founder Sam Altman basically said this: AI models currently are the stupidest models the models will ever be. So of course, yesterday, OpenAI came out with a new version of its DALL-E engine, which then, using exactly the same prompt that I was trying last week, which failed, this week it worked. But it also does, it does very much show that this technology is going to become more powerful, driven by the billions of investment and focus, that is globally accelerating the innovation side of this. But what it also illustrates is the fact that the trust is based on. So having that context, having that idea when you're doing the trust fall exercise, part of the reason that works is because you know, or the people that you're in the exercise with, and you trust that they will behave in a certain way, that you trust they're not going to drop you. Same thing with these models. You can't just, take a large across the spectrum of the stuff that's out there on the internet, even one that's been well conditioned, and expect it to perform in the specific context of your business. Every enterprise is different. Every enterprise has its own language for describing the business that they are in. And I've worked across a number of different industries and market segments and domains, and I can tell you that each, if you're talking mining operations, for example, when I worked in the mining industry, even though they were under the same umbrella company, every single mine site was quite different in terms of the way it described the underground mining operation, the way it handled the specificity of work tickets, and health and safety data, all of these things. Same in the AEC domain. While you may have an architectural firm that has standardized processes for delivering and modeling and designing projects and whatnot, each building site is quite different in terms of the way it has to be set up, from understanding the as-built, if there is such, that type of thing going on, the way the design is then connected to that, and the way the information is provided, and the interaction with the construction firm, and so on. So it's this idea of context is really quite important, and it's important to get that right in order for ensuring that the models consistently provide answers that can be trusted in the context of that business, that work, that site, that building, so that you get reliable, accurate answers that also honor the security requirements. And I'll speak a little bit more about this as well. So if you go to the next slide, you can't just take and data, toss them into an LLM shredder and expect to get trustworthy answers out of one of these things. And this is the POC, the proof of concept trap we do see enterprises and businesses falling into. It's like, hey, we can grab a large language model and a little bit of code off the internet somewhere, spin this thing up, stuff some PDFs into it, and voila, you can talk to the PDFs and get nice answers back out of it. And that can work to a certain extent at a small scale. But certainly what we've found is we've gotten into doing a number of enterprise scale implementations with tens of thousands or hundreds of thousands of PDFs. The complexity increases commensurate with the amount of information that you're providing. This gets into the nature of the way documents are set up, and the way these models handle the context associated with the data that they're being given. PDFs are very complicated, and I have done other sessions on this subject that you can look up and find. PDFs and documents, Word documents, Office documents, CAD drawings, all of these sorts of things, files contain a blend of the messy mix of scanned images, inconsistent formatting, handwritten notes, forms-based data, all kinds of things get put into these types of documents. So even if they contain that valuable knowledge somewhere in there, just sticking these things in and kind of sort of breaking them up doesn't guarantee that you're going to get good answers back. If you go to the next slide, so taking one of these proof of concept type approaches and then dumping all your company's PDFs, spreadsheets, reports, et cetera, into a system without any kind of structure and expecting an LLM to magically make sense of it all is a false promise. We talk about this, and Eric and Taylor talked about this in the context of what they refer to as a data swamp. If you're not, and you can't build a good foundation for trust on a swamp, this will result worse. And another big risk with this sort of an approach is if you don't invest in a structured approach to processing your PDF files and a well thought out one, security also then becomes a major challenge. And this again gets into some of the history behind why we've ended up with this thing called a file. And the security associated with a file, as many of you will know, is handled at the level of the container, the file itself. You either have access to that file or you don't. That is the way pretty much all of the network type systems, whether you're talking SharePoint or the legacy network drives or any of these cloud hosting things work. If you're given that access to that file, you have access to everything in it. By the same token, if you happen to have a whole pile of PDF files that you're taking and you're putting into the context of a large language model without thinking about the security aspects of it, how you're breaking those files down, if you've got documents, say health and safety reports, or perhaps financials from a company, and so on, that have a combination of less secure information and more secure information, the LLM has no way of understanding which of these things are supposed to go to which people when they're asking questions about it. And the fact it takes a lot of work to build trust. It only takes one bad answer or one answer that exposes high risk information, private information or otherwise, for users to lose trust in that system. If you go to the next slide. So trust is an earned thing. In order for trust to be built in these systems, there needs to be a framework that is in place, a foundation that allows that trust to be created. And that goes from end to end. You need to have the trust kind of in the data that are coming in. So your acquisition of your data is important to think about this, how you're getting the PDF files in the first place, how you're processing them, how you're curating them, and then how you're connecting those bits of data that are coming through the PDF processing cycle to the structured data the organization has about the people that work in the organization, the types of definitions for things, the security context, and so on. That all has to be thought and put in place with this. The other thing that's quite important to think about with this as well is the fact that just putting some code in place and expecting that to function long term is also not a realistic expectation. You need to also consider the standard practices associated with proper software development lifecycle things. These models, as I showed earlier, change very quickly. So that means the code around them is also changing very quickly. You need ways of managing that code. You need to have proper continuous integration deployment. You need to have testing in place, both testing for the code itself and also evaluation testing, which is a rapidly moving domain as well in terms of assessing how good and the quality of the answers that are coming out of the model are. These are all important considerations. And if you go to the next slide, the data itself. So these files, the documents that are being produced in your organization, they're not static. They change over time. Your sources change. So another area that you can lose trust is if somebody asks a question and then they get back an old answer, they make a decision on that, and then they've made a mistake because maybe a bit of information or something has changed about a design or a report. That bit of information should have been surfaced. The other piece of information should have been dropped out of scope. So the system that you're building up, this intelligent data processing pipeline, as we often call it, needs to think about that aspect and factor that in as well. You need this repeatable, reliable platform that provides the LLM proper enterprise context that has standardized processes, mapping out the lineage of the data from the source to the application that does create this high quality foundation to ensure these models are grounded. And if we go to the next slide here, this also then enables something else that Farhad's going to talk a bit about today as well, is to get the high quality answers back out of these sorts of systems as well. People ask questions in many different ways. Having this type of a well thought out structure that exists inside of that you produce as part of the processing allows you to then have different strategies for answering questions based on the fact in the context of the user, the type of the data, and the nature of the way they're asking the question. Is it a very specific question? Is it a general question? Are there different ways they could ask the question? There are a bunch of different strategies associated with how you go about handling a question that a person has asked, and the way you target that into the corpus for them making sure you're retrieving relevant chunks of information and sufficient information that the large language model can synthesize an appropriate response to that question. This, again, is quite an important factor in trust. If a person gets an answer back that is either too short or does not provide them the detail that they need, or worse, provides detail that is not actually contextually relevant to the question they're asking, that again is a basis for loss of trust. So now I'm going to turn it over to Farhad, who's going to speak a bit about some of the technology and ways that in this platform that he's put together that he'll share with you that will talk about addressing some of these aspects.
Awesome. Thank you very much, Mike. So starting from here, we'll review first some of the key concepts of RAG applications. We have already gone through them, so we just make it quick. So these principles or these primary the components of a RAG application includes indexing, which effectively means parsing the document, extracting text, and chunking those texts. So like at a document, we can do our chunking at the page level, or we can do it like at the sub-page level. And indexing effectively means once we have chunked the text, we also vectorize that text, which effectively is generating a mathematical representation of that text chunk or that data. And then we are going to store that embeddings along with metadata and the parse text into a vector store. So like two popular options are vector DB database or graph database. And the two other steps are the retrieval. That's also pretty important. So this is one of the steps that we have improved over the previous webinar. And what it effectively means is that based on the query that's been submitted, we fetch and retrieve the relevant chunks from the documents. And for that to happen, we also need to have a mathematical representation of the query, which is going to be a vector. And we have a bunch of vectors based on the documents that we have already indexed, and then we find what are the most similar vectors. So that similarity could be based on the angle between vectors and based on the distance between vectors, and each one of them has a term, either cosine similarity, Euclidean distance, or just a simple dot product of vectors. And finally, once we have retrieved those text chunks, we'll pass them down to the large language model, and then large language model with a specific instruction will produce the answer relevant to the question that's been submitted by the user. So yeah, these are very like bare minimum steps that's required in a RAG application. And in terms of some of the terminologies that you have been hearing, so we will go over real quick, maybe not all of them, but mainly the multimodal RAG. So with so many open source packages like LangChain and Llama Index, effectively they abstract out a lot of the steps to build a RAG pipeline. It's pretty easy to build a naive RAG, the one that just to echo what Mike mentioned, which has the bare minimum components. It's pretty straightforward, but developing a flexible, secure, and production-ready RAG application remains challenging and it requires expertise. And that's what we have been trying in these webinars to make it simple. Just put together a source code which is publicly available, so you as a developer working in an enterprise can get started with that and build on the top of that. There are a few key terms. I mean, these terms are like vanilla RAG, advanced RAG, multimodal RAG, and agentic RAG. So especially agentic RAG, you have been hearing a lot. But we have gone through them. As for the multimodal RAG, it effectively means that it has the components that ensure accuracy. So we set up some evaluation metrics for different parts of the pipeline, and it has scalability component to handle high traffic with low inference time, and it's transparent, so it retrieves the source text, especially in these application that we are going to have a live demo real quick. We want to also show that the best way to retrieve information, like the source text, would be to retrieve like a screenshot of where the information is coming from, so the user can exactly see the source data as is without any manipulation. And then like another thing which is also pretty important is that you should be able to handle multiple data modality, for instance, text and images. It's particularly crucial for many company like reports and documents, because a lot of them have visual data that should be incorporated into the RAG system. So in this demo we are going to showcase in a bit, it has so you're going also to have access to that. We process both the images and the text using GPT-4o, which is a multimodal large language model, but this could be any other LLM. Especially we have been like seeing like a lot of open source models that are like very decent models. For instance, the one that have recently been released by Google, Gemma 3, that's been great. So then the best way would be, as a next step, would be to set up the on-prem large language model instead of hitting the endpoint of third-party companies. The best way would be to host your large language model at the enterprise. But in this project, in this application, we are just using the Azure resources along with Llama Index. So everything is contained. So even if like when we do the endpoint, like large language model endpoint call, we do that within Azure. So we never go outside Azure. And we also use Llama Index for parsing. So these are the two basically companies that we leverage in this project. And we have gone through the front end and back end, but just real quick on the front end, it's pretty like simplistic and minimalistic. So I really like that. It has all the components you need, but at the same time, you can build on top of that, add a lot of features to it. It's been built on the top of using React. And like we have used the Azure Container Registry in order to package in order to host the image, the Docker image of the source code. Along with Azure App Services, we take care of all the incoming traffic and setting up the custom DNS. And then we have Azure Entra that's been used in order to get the token and for authentication, because as you see in here, that you will also see in the live demo, you won't be able, so you can have access to the front end, but you won't be able to submit any query or just like run any of these buttons without like signing in or without refreshing or getting the token. So you will see that in a second. And on the backend side, so the good thing is that in this project, like any like other production ready like applications, we try to like isolate different pieces or modules as much as possible. So we have like isolated front end from the backend. They are totally like different repo, different source code. And the backend has two separate workflows and two separate endpoints just to trigger that. One is indexing, which effectively what it does, it indexes a new document whenever you want to index your new document, or you want to re-index your existing document. You can leverage this workflow. And there is another endpoint, which is the query endpoint, when you want to submit your query. And we have written that using Python and Fast API just for the API, Fast API. And as for the resources, again, we have used Azure Container Registry. We have used Azure App Services, the Entra for authentication, because like the front end, for the back end, in order to work, it needs to pass the token so that it allows for just submitting the query. And we'll see that in a second. And then we have the Azure Key Vault, and that's for storage of the environment variables. And we have Azure AI Search. So that's the resource that now we are using for storing the indexes. So as I mentioned before, when we index a document, we need to store them. It's either like a vector database or a graph database. And Azure has this resource that's called Azure AI Search that abstract out a lot of difficulties. It's serverless and it takes care of a lot of steps. And so we are leveraging that. Like so for storing our indexes, although like they do a lot more. And we are using Azure OpenAI Studio, and we deploy like a bunch of models that we need. In this case, we need a couple of models. One is a multimodal model. In this case, it's pt2, and we use an embedding model. And all has been used by the Azure OpenAI endpoints. And then finally, we are using Azure Blob Storage. So whenever like we do the parsing and we extract some images from each page of the document, we also store them within Azure Blob Storage so that during the conversation, we can also retrieve them and we can like return them based on the user query. So before going a little bit deep into some of the additional features that we have added, I'm going to quickly show a live demo. So we have seen that before. The main part is that it requires authentication in order to have access to the front end, and you can see that I've already signed in. But if I use the same code, and if I use it within incognito in Chrome or in private in Edge, so it requires me just to sign in, and then I have to use like my email address and the factor authentication to be able to get the token. And since I've already signed in, I just need to refresh my token. I will go to the Azure Entra and it will grab the token. And as you can see that the token has been received. And then now I have access to like these two buttons, which are effectively two different workflows. So we are going to just start with like asking a question. And so far I've already indexed two documents. One is a document about like the big book of Databricks, I believe. And like both of them are publicly available. So that's one of them. And the other one is, I believe, is a financial report that's also publicly available by PwC. And I'm going to ask one question. We have gone through them before, so I've already have the question in terms of scaling AI/ML. What percentage of executives disagree with this statement? And this is a question that I typically use for benchmarking. And I submit the question, and we can see if I run that. You can also see what's happening in the background. Yeah, this is just in the background, just to see what's happening. So I just started the live logo stream. Sometimes there's a little bit of lag, but it effectively shows what's happening on the back end when we run the query. So I just started the live logo stream. So when it starts generating some data, I will show. But so far, what's happening is that it generated a response. The response says like 8% disagree, and it's like after providing some information, it provides the final answer. It took about 11 seconds, which is pretty decent. It gives us which document is coming from. Let's say that you have thousands of documents, and that really helps you to know like which document you should grab this information from. And then you have your screenshots of which pages the information is coming from. So this is page 12. And if we look at this figure, we will see that this is where the information is coming from. And yeah, that's great. So there is nothing better than having a screenshot like that just to see where the source is. And this really helps with like transparency. And in addition to that, another point which is quite important is that we want to make sure that our RAG application do not generate response by training data. In other words, it doesn't hallucinate. And another test that we can do is just ask a question about the information that it doesn't have. For instance, what React agent stands for. I've also tried that before. So if I ask it now, it shouldn't have any information about that. So we can also see on the backend now, like it's passing down the token and it starts preparing the environment. It looks at like all the documents it has so far. It has access to these 2 documents. And then it retrieves 5 nodes. It should also, and then re-rank them. And then these are the 3 images that's been retrieved. And yeah, the answer should have been provided. So it says the query what React agent stands for cannot be answered based on the provided parse markdown. This is exactly what we're looking for. If we don't have that information in our, like we haven't indexed that, we don't have it in our repository, we don't want the RAG application to provide any answer, which is fantastic. And now we want to just do like we want to like add that information. So that information is in this document, so which is like a PowerPoint, also just to show that it can also handle not just PDF but also the PowerPoint. And this time, this is as simple as we are going to use another like workflow, which is index new documents. So when I press the index new documents, it starts like another workflow. So it passed down the token. And now this time it starts indexing the documents. It will go through all the documents. And because we already have, like it found 3 files, we already have 2 documents have already been indexed, and it will start with webinar 1, which is the new document we just added. So it's in progress, but when I show the logs, it waits for all the processes to be done, and then it will just publish the whole thing all at once. But it's what it's doing effectively is taking a screenshot from all the pages, parse the text, generate an embedding, and then store and upload the images into Azure Blob Storage, which also have a SAS token that's also pretty private. And then also store the indexes in Azure AI Search. So it should be done real quick. So that's be done. So it was able to generate a screenshot from all the 15 pages, uploaded them. So the 15 successful uploads and 100% of generating, embeddings for all the pages. And it's been done. And it also provides us a summary for all the documents. So we can also have a nice summary for all the documents. And now I'm going to ask the same question again. And again, we can also see, it passes down the token and just starts going through like all the documents, and it selects the webinar 1 just to find the answer, because that was the document that has the answer. And the answer is the React stands for reasoning and acting, and this is the information. Information is coming from this document, and it has received the information from this part. So React stands for reasoning and acting. If I go to the document, which is a PowerPoint, I should be able to find the answer on page 8. So if I go to page 8, that should be where the answer is, which is fantastic. So this is exactly what we are expecting a reliable, accountable RAG application to present for us. And now I'm going to just talk a little bit about some of the additional features that we have added so far, and also look at the source code and just show you where you can find the source code, so that if you're a developer, you can set it up and then start building on the top of that to build it at your enterprise. Going back to the slide deck, we'll see previously what we had was we were doing the chunking at the page level, but what we have done, what we have implemented is that we have added a new strategy that's called hierarchical parsing, and we are leveraging like llama index abstraction for that. And effectively during the parsing, excuse me, during the parsing, we'll generate a node, which is called the parents node. And that will include the page level text along with metadata and the embeddings. And then we have children nodes. And children nodes are going to include like a part of the page. And the main logic behind that is when you ask a question, sometimes the question is about like is general, and in order to answer to the question, you need to have the whole page embedded because it has it will encapsulate the semantic meaning of the whole page. And sometimes your question is about like some information that's been provided in one paragraph. And in that case, you want to do the separate, you want to have separate embeddings for each one of the paragraphs. So then your RAG application will handle both general and specific questions. And that's what's happening in here. We have both parents node and we have children node. But what's happening, the issue that happens with this hierarchical parsing is that let's say when you ask a question and think that at the page level you have like 5, 10 child nodes, all of a sudden you might receive five retrieved text chunks or 10 retrieved text chunks, and all of them are from the same document, because effectively all of these text chunks should have pretty much similar semantic meaning, and that could provide some problem for the accuracy of the RAG. And to solve this issue, we are using like a separate retrieval. And that separate retrieval, what it does is that we have a base retriever. So effectively just return the text chunk based on the similarity of that text chunk with respect to the submitted query. And then we have a separate retrieval that's called auto merging retriever that will look at all these nodes that's been retrieved, and we'll look at their parents node. If, for instance, two of them or however number of them are coming from the same parent node or same document, what it does, it will merge them together and it will replace them with the parents node. For instance, in this case, it has retrieved like this part of the document and this part of the document. So it effectively means that this question needs to be responded by the whole page, because that page is likely to have some information that's been needed to answer to the question. And that's why this auto merging is pretty important, because first, like we pass down less information to a large language model, it's going to be more efficient. It's going to like burn less tokens. And second, when we have a query that needs to be answered from like several documents or several pages, this way we don't only get answer from one page. So all the answers from that page is going to be replaced by its parent page, and then we're going to have like some of the other pieces or other information from different parts of the document. This way, when you ask a question, so the application is able to connect the dots and answer you based on information that's been provided in different places, different documents. And that's extremely important for a production-ready application. And another step that's quite important, that's more like a DevOps side, is setting up CI/CD like infrastructure as code, the IAC. For CI/CD, we have used GitHub Action. What it does, it will check out the code. It does the Azure authentication, and it build and push the Docker image of the source code every time that you make a new commit or make a new change to the source code. And also we are leveraging Terraform for IAC. So what it does, it will just look at any changes that we want to make to our like resources. For instance, we are now seeing a lot more traffic. We want to just go to another tier of the app services to handle that traffic. So we can just simply change that in the code, maybe one line of the code, and then the like CI/CD will take care of the whole thing. It will just deploy the infrastructure for us to Azure. We don't need to be worried about anything. And then we have Terraform, which take care of the infrastructure deployment. It look at your resource group. It track all the resources within that resource group. For this project, we have Azure Container Registry. We have app services for managing Docker, and we have like key vault secrets for and also access policies. And also we have Azure AI Search, or it's also called Cognitive Search. And we have those open AI services and storage accounts and the blob storage. So effectively the same thing. Just to quickly show you where you can grab the code. So just simply go to GitHub and my name. And then if you go to the repo, that should be the first and second one that comes up. The first one is the backend, the second one is the front end. On the backend side, just to quickly show you like these additions, one is the Terraform. So you can see all the code on the infrastructure, and then we have the workflow or the GitHub action. The GitHub action is using this workflow in order to set up CI/CD, and you can also like see like once you have it set up, you can just simply like do the deployment and run the deployment, and it will just deploy all the new code and infrastructure in your Azure. And on the setting also, you can obviously set up your secrets, everything that you need in your source code. Yeah, that's pretty much it. In this session and the previous one, the main goal was to set up like a basic source code, so you can build like an MVP, minimum viable product, and a production ready application, a RAG application at your enterprise. And that's the last monthly session that we have. We will have like some upcoming sessions on the need basis as we like do more development, but it's not going to be like on a monthly basis as we used to have. And yeah, thank you very much. So far, like we have handled like these 4 cases we talked about, and we wanted to add like some of the next steps that you as a company want to do. One, which is extremely important, is evaluation. We want to set up some metrics so it evaluates the answer that's been generated. So the next step would be agentic workflow, so that a bunch of agents work on different documents for you. That's quite important. This is kind of like nice to have, but it's getting important, especially in 2025, that this is the agentic AI year. And finally, it's important that you leverage on-prem open source LLMs. At some point, you can definitely start with this, but I mean, down the road in 2 years, 5 years, 10 years, you can just switch into on-prem open source LLM. A bunch of references, and thank you. Yeah, we don't have a lot of crowd, but let us know if there is any question. Mike, anything to add? Did I miss anything? Do you have anything to add?
No, I think that covered the key points. You know, as kind of tying it back into the initial kind of theme on the trust side of it. You know, that's something that we've been really trying to focus on in a number of different forums, as I'd mentioned at the start, with the lecture that Eric and Taylor and Tony did at DataCon, and then the article that was published in Digital Journal. The aspect of trust is super important with these things, and it does come down to the fact that if you have a well thought out infrastructure, and you do take the time to analyze the data that you're putting into these things, that's also quite important. And then determining the optimal way of kind of breaking those data down and connecting the unstructured data that are coming in from PDFs with the other information that you may have in the enterprise context makes quite a big difference in terms of the quality of the answers that are coming back. As Farhad was illustrating, there's a lot of really useful things you can do to help with the trust aspect by providing that transparency. And transparency, of course, is showing the folks who are asking the question where the answers are coming from, which documents and which parts of the documents, so that it's the answer is well grounded and anchored in the context of your organization. And when you do that, that I think helps people quite a bit. They then can see and understand the response they're getting, that they know it's coming from information that's been validated and that is reliable and so on. And the fact the model, the way it's been set up with Farhad's design here, will say and indicate the fact that, okay, I cannot answer this question because of the fact that I don't have information available in the corpus that's been provided to me is also pretty critical. Because an unbounded model, of course, will attempt to generate an answer, typically known as a hallucination, regardless of whether or not the actual factual information is there. And that's actually even a worse scenario in a lot of ways, in that if you're getting inside, an enterprise, if you've got one of these systems or a system like this that's been exposed to a client, what you don't want to have happen is you do not want to have a model generating answers that are not anchored in your organization's context.
Yeah, exactly. And as I mentioned, as a next step, the important thing is that all we talked about, like Mike talked about, I showcased, should be quantitatively also accessible. When any transaction happens, like any query has been submitted, any answer that's been generated, there should be some quantitative metrics to provide some assessment in terms of the hallucination, like the accuracy of the retrieved chunks, the accuracy of the content that's been generated by the synthesis step. And that's pretty critical. And that's something that we will likely also add to the source code. So just when you look at the source code, we will it's like keep evolving. But you just feel free to use it, and then you can build on top of it on your own.
Yeah, that's a good point. Like testing and evaluating these types of systems is also an interesting exercise, because the testing, of course, unlike typical software development testing, which also needs to be a feature of these in an enterprise or like an actual proper implementation context, unit testing and those sorts of typical software development lifecycle patterns. But this testing of model responses and retrieval augmented generation responses is also quite a new thing because it's non-deterministic. The way you ask the question, the nature of the response, like all this stuff, I think it's still an evolving domain in terms of very much how you go about assessing the nature of the quality of the responses that are coming back out of these types of systems as well. I did notice that LangChain has produced just recently a couple of evaluation systems, as they're I think now being called, that are frameworks for doing this, and there's a number of them that are out there that are evolving. So it's an area that we're keeping a close eye on, and it might actually be a subject for potentially a future webinar as we get kind of more insight into patterns around that part of the equation.
Yeah, absolutely. We have one session on upper bound in Edmonton. I suppose it's in May 22nd, and we are likely gonna double into this. And yeah, we likely are going to just extend this and use some agentic workflow, wrap some agentic workflow around that, and add some evaluation for it. Cool, thanks, and appreciate it. I think we're getting pretty good at it, so we managed to finish it in 15 minutes. We typically go like about 1 hour. I see Chris is typing, hopefully. Oh, awesome. Yeah, no worries. Thanks for joining us. Take care, guys. Thanks.